Today, in this video, I am going to explain the meaning of acceleration due to gravity. The acceleration due to gravity, the term, it is represented by the letter G. Here, first you should know what is acceleration due to gravity. When any body moves in a straight line, for example, if any car or truck, they are moving in a straight line, the bodies, since they are moving in a straight line, they will have linear acceleration. That acceleration is because of the engine. But if anything is dropped from certain height, there the bodies are accelerated due to gravity. That's why if you split the term acceleration due to gravity, the first part is acceleration due to that due to that is linked with which one gravity. That acceleration is purely because of gravitational force. That's why the G is called as acceleration due to gravity. In the case of truck or bus, when they are moving in a straight line on the road, there the acceleration is denoted by the letter A. Now we are going to deal with free falling body and we are going to learn what is G. Very patiently you have to learn. Here, let us imagine a tall tower. Here, if something is about to fall from certain height, now we are going to calculate the various parameters. Let us imagine the initial fall is 0. Are you clear? The initial height of fall is 0. By the time the initial velocity to be taken as 0, when all those things happen, when the time is equal to 0, it is about to fall. Therefore, when time is equal to 0, initial velocity is 0 and the height of fall is also 0. Are you clear? Now, we have to calculate what will happen after 1 second. Are you clear? You should have a stop clock with you. You have to count. Clear? You have to count how long it falls. Is clear? From that particular height. That is h1 to be found out. And then you have to calculate the velocity also. Velocity with which the body it goes down. That can be calculated. Now, what is the formula? Here, two formulas are introduced. V is equal to gt. That is to be used to calculate the velocity of the free falling body. And you can measure the height of fall. That height of fall can be calculated by h is equal to half gt square. So these two formulas, they will be taught in the higher class, or you may have already learned it in the lower class in 9th standard level. So this v is equal to gt half gt square h formula, both they could be derived from equation of motion. Are you clear? So here we'll calculate what is the value of the v1 velocity after 1 second. What is the height of travel, height of fall after 1 second? What is the formula? v1 is equal to gt1. G value, that one was already calculated. Assume that the G value is 9.8. 9.8 into 1 second is equal to v1 is equal to 9.8 meter per second. That is, after the fall, after 1 second, the body, its velocity will be 9.8 meter per second. Initially, what is the velocity? 0 meter per second. Now the new velocity is 9.8 meter per second after 1 second. Now we will calculate the height of the fall. Half gt1 square. Substitute half 9.8. After 1 second we are calculating. After calculation you are getting 4.9 meters. The meaning is, after 1 second, the body travels. How long it travels? The body, it covers a distance of 4.9 meter. Now you calculate the distance difference. That is, initially it was at 0th meter. Now it has covered the distance of 4.9. 4.9 minus 0 is equal to 4.9 meter. So that is height difference between this position and this position. Now we are going to calculate the most important thing. What is this? G. Now we have to prove that the G value is constant in each and every moment. G is equal to, what is the formula? Final velocity minus initial velocity divided by time interval. Final velocity is, what is the final velocity here? 9.8. Initial velocity is 0 meter per second. Here it should be written as 0 meter per second. Are you clear? So substitute both the two. Final velocity minus initial velocity divided by the time difference is 1 second. Substitute, you will get the value of G is equal to 9.8 meter per second square. It shows that when it falls, the body is accelerated at the rate of 9.8 meter per second square. So this much amount of acceleration that is produced in the case of the free falling body when it is descending down. Now we will calculate what happens clear in the after the 2 second. Are you clear? By using stop clock, if it is allowed to fall for 2 seconds, what are the things which are happening? What is the formula to calculate the new velocity v2? v2 is equal to gt2. G value is 9.8. After 2 seconds you are calculating into 2. Substitute, the value is velocity is 19.6 meter. The meaning is when it is dropped, what will happen? After 2 seconds it reaches here. When it is traveling, its velocity will be equal to how much? 19.6 meter per second. Are you clear? At the end of 2 seconds, what would be the velocity? 19.6 meter per second. What would be the height? h2 is equal to half gt2 square is equal to half into 9.8. After 2 seconds we are calculating 2 square. Calculate everything. Now you are able to calculate the height up to which it is coming down. Are you clear? The total height of travel is how much? 19.6 meters. Are you clear? In the first second it travels just 4.9 meter. Are you clear? In this second, what happens? That is after 2 seconds, if it travels right from beginning, right from the origin point, it travels a distance of 19.6 meters. Now we'll calculate the height difference. The height difference between this 4.9 and 19.6 is how much? 14.7 meters. In the first second, it covers the distance of 4.9 meter. இந்த செகண்ட் அதாவது ரெண்டாவது செகண்ட் நடக்கும்போது இது ட்ராவல் பண்ணுற டிஸ்டன்ஸ் என்ன? 14.7 மீட்டர். ஹியர் ஆல்சோ த டைம் கேப் இஸ் 1 செகண்ட். ஹியர் ஆல்சோ த டைம் கேப் இஸ் 1 செகண்ட். இந்த ஃபஸ்ட்டு டைம் கேப் 1 செகண்ட், இட் ட்ராவல்ஸ் அ டிஸ்டன்ஸ் ஆஃப் 4.9 மீட்டர். But in the second is going on, it covers a greater distance. It shows that the body is accelerated. That is the important thing. Again you calculate the g value. G value is equal to final velocity minus initial velocity. Are you clear? Here this velocity must be taken as the initial velocity. Here after 2 seconds this velocity must be taken as final velocity. So final velocity minus initial velocity is equal to 19.6 meter per second and then 9.8 meter per second. The time interval is 2 seconds minus 1 second. Again after calculation you are getting g value as 9.8 meter per second square. Look at that. In the previous case also, that is after 1 second, the g value is 9.8 meter per second square. After 2 seconds also, the g value is 9.8 meter per second square. It is a constant. Other parameters will vary, but g won't it vary. Are you clear? Now we will calculate what happens in the third second. Now you are going to calculate what would be the velocity of the falling body after third second. Calculate using the formula gt3, that is after third second. Substitute 9.8 into 3. After calculation you are getting 29.4 meter per second. The meaning is if it is allowed to fall right from here, so it reaches here. When it reaches here, its velocity will be 29.4 meter per second. Compared to after 2 seconds, look at that, its velocity is just 19.6. Tell me whether the velocity is increased or not. Since the velocity is increased, it shows that the body is accelerated. Now we'll calculate the height of fall. So what is the formula? h3 is equal to half gt2 square. Substitute everything, calculate. We are able to calculate the height of fall after third second. So if it is dropped right from here, after third second, it covers the distance of 44.1 meter. 44.1 meter. Are you clear? 44.1 meter distance is covered by that falling body. Are you clear? Now you calculate the height difference. Are you clear? In the second, it covers a distance of 19.6 meter alone. In the third second, it covers a distance of 44.1 meter. What is the height difference? 24.5 meter. Look at that. In the first second, it covers 4.9 meter. The second, it covers a distance of 14.7 meter. In the third second, when the third second is going on, it covers the distance of 24.5 meter. It shows that here the distance covered is less. Here the distance covered is little bit more. Here the distance covered is further increased. It shows that the body is accelerated. Again, you calculate g value. G value is final velocity here. At that point, the final velocity is v3. Are you clear? And this here at that point, this final velocity should be taken as v2. v3 minus v2 divided by t3 minus t2. v3 value is known, 29.4 meter per second, minus what is the initial velocity after 2 seconds. Here we have calculated one velocity now, that is nothing but what is this velocity is initial velocity with respect to that point. Substitute. Now what is the time difference? Now here third second is going on, third second is over, 3 second minus 2 second, substitute, calculate. Again you are getting g value as 9.8 meter per second square. The ultimate aim of preparing this video is you should know that the body is accelerated at the rate of 9.8 meter per second square. The first second also the acceleration is 9.8 meter per second square. The second also 9.8 meter per second square. And the third second is going on, there also the value of g is 9.8 meter per second square. So if any object is dropped from certain height on the surface of the earth, that body gets accelerated at the rate of 9.8 meter per second square. Don't forget the value. This is only meant for earth. This value of g, that one will vary from planet to planet. This is only for earth. If any gravitational related problems are to be solved, then the value of g, this value must be 9.8 meter per second square must be used. Are you clear? So just I have taken a very elaborate thing about the value of g. Understood? Learn the content properly, understand the concept. Thank you.